The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, and good evening, everyone, and welcome to today's webinar hosted by NXP with our partners at Embedded Access and PHYTEC. Today, we'll be discussing multi-core processing with the i.MX RT1170 CPU, NXP's MQX RTOS, and PHYTEC's phyCORE-RT1170 SOM. Today's panelists include Daniel Ho, a product marketer from NXP, Doug Bruce, the Vice President at Embedded Access Incorporated, and Kyle Barrett from PHYTEC. The key takeaways from today's webinar include MQX as an ideal selection for the RT1170 CPU, phyCORE-RT1170 is an ideal hardware platform for an RT1170 based design, and NXP providing a complete solution for the RT1170. During the webinar, you can type your questions in the question box found in the GoToWebinar control panel on the right-hand side, and we will address as many questions as we can during the live Q&A at the end of the webinar. In the handout section, you will find today's presentation as well. I would like to, we've had a lot of traction, a lot of interest in this webinar, and so before we kick it off, I just wanted to ask the attendees to please take a moment and type in the chat window just a short statement about what aspect of this webinar particularly caught your attention. We'd love to collect that information so that we can create more valuable content for you in the future. So with that being said, as you're typing those comments in, I will go ahead and change over to let Daniel be the presenter and get us started with our presentation. Daniel, go ahead.
Thank you, Rachel. Can everybody hear me?
I can hear you.
Okay, cool. So firstly, good morning, good evening, wherever you're in the world. Welcome to the webinar. My name is Daniel Ho. I'm a product marketer for NXP, focusing on MCUs and NPUs for our business line called Secure Connected Edge. And I'm going to kick off this webinar by introducing the i.MX RT series, and especially, kind of focusing on the i.MX RT1170 dual core crossover MCUs. So let's go ahead and start it. So first of all, I'd like to kind of take a high-level overlook on, the product portfolio we offer as our business line. We are very much focusing on industrial and IoT applications, and we have a very wide range of MCUs plus the application processors for different kind of applications. The way to look at the scale on the very left-hand side, bottom left, that will be your traditional, Cortex-M core-based MCUs. So we have LPC MCUs and Kinetis MCUs, two of our pretty legacy and popular brands of MCUs for a variety of applications like control, real-time sensor fusion, wireless connectivity, and we also have a new platform of the next generation of our general purpose MCUs coming up really shortly. That's called the MQX. So that's going to have a very nice convergence of the LPC and Kinetis. If you look at the very right-hand side, those are our application processors, meaning those are Cortex A core based, running your Linux and Android system operating systems. We have the i.MX, very much focusing on multimedia, video, audio processing, and we also have Layerscape for networking. So the i.MX RT series is really what we call the crossover. The RT stands for real time. So from that, you can kind of get an idea how we come up with this product series. It's basically the idea of really combining the good or the advantages from both the real time, MCUs and the operating system based MPUs. And that's the definition of the i.MX RT crossover MCUs. So we kind of managed to bring a lot of performance and integration from our i.MX family, that's the application processors, down to a MCU-based platform. By saying that, meaning that all the i.MX RT crossover MCUs is running on Cortex-M core, a real-time core. And then we also have a lot of, ease of use, real-time processing capability, brought by the Cortex-M core. So it's really a very good combination of, a real-time processing plus a lot of good performance and integration. And that's the, especially the i.MX RT1170, that's, basically in the industry, the first gigahertz performance MCU out here. So with that, you'll get the ease of use aspect of the MCU when it comes to tool chain, having the real-time operating system, and also easy to design as in power. And we also have a very good rich integration that I'm going to show you guys in a short bit. And the application can be fit into a broad range of different market, including like smart home, consumer audio, all the way to healthcare, and even like for automotive, we can use the i.MX RT for either in-vehicle networking or in-vehicle HMI. So let's zoom in a little bit on, what are the families available in the i.MX RT. I like to kind of categorize that into two major categories. This i.MX RT 3-digit, what we call it, including the i.MX RT 600 and 500. Those are, viewed as more or less like a little brothers to the other i.MX RTs. Those are Cortex-M 33 core based, really very much focusing on, reduced power consumptions, where, you'll see the i.MX RT 600 fit into a lot of wearable devices with audio processing capability because of the DSP integrated onto the device. You also see the i.MX RT 500 in a lot of wearable, like your smartwatch applications, where it does have a 2D GPU integrated, and with, at the same time, the low power aspect, where, if you're running your wearable designs on the battery, that's really comes in handy. But the majority of the i.MX RT are actually really sitting on, the i.MX RT 4-digit. So that's where, we really focus on industrial and IoT applications. This is a very high level categorization of the different RT 4-digit. The way to look at it, we firstly have the very kind of general purpose i.MX RTs. That's the RT1010, the RT1020. The single core Cortex-M7 goes up to 500 megahertz of performance. We also have a very rich, your typical, mirror interfaces, since most of the RTs are flashless. That gives you a very flexible and quick interface with external flash to achieve a top performance. And we also have a rich peripheral integration, your standard, essential peripherals that the MCU would have on the RT1010 or RT1020. And then moving on to the right, that will be, the RT1050, 1060. So those ones are, we managed to add more driving and HMI capability onto it. And by saying that, I mean, we have more, waveform output capabilities with those devices, like the motor control PWMs. We also have, 2D accelerations for, either camera interface with CSI or the LCD display. And then moving on to the high performance, that's really, in the spotlight of today's webinar. That's the i.MX RT1170 and 1160. So the way to look at it, you might already have figured out is that, if you see the 10, that's actually the single core version. And if you see the 11, those are the dual core families. So the RT1170 and the 1160 are both dual core MCUs that goes up to all the way to a 1 gigahertz performance, very well into a realm of a typical, application processor performance that you would see. And we, kind of take the MCUs to another level by adding, MIPI, CSI, DSI, and also even like a 2D GPU. So providing a lot of, high performance graphic capabilities and camera interface capabilities. Also things like the time sensitive network MAC to do, high speed, Ethernet connectivity. And then we have another branch here where we just kind of announced last year. We're having early adopter programs right now. That's the i.MX RT1170. So for that one, it's a branched out of the existing families where we actually really focusing on industrial Ethernet, where it will have a hardware switch to do a lot of fast switching for industrial Ethernet, even including the EtherCAT. So we are keeping innovating on all the RTs. We have expansions in, for example, the i.MX RT1040, the 1060, and we also are launching new RTs like the 1180 to do, more different applications. So let's zoom in on the 1170, the RT1170. This is really a dual core high performance MCU. There are a lot of features, as you can see on the slide. You can view this as currently the superset of all the RT4 digits. So any of the other RT4 digits are kind of like a subset of all the features that the RT1170 provide. A lot of sections in there, including, the dual core performance with the M7 and M4. We have internal memories, high speed, tightly coupled memories offered, and also external memory interfaces. We also have a lot of security features integrated onto the device. So aside from, reading all the bullet points, I'm going to kind of zoom into some typical applications by using some of the features that the 1170 provide. For example, the multimedia. I'm actually showing a turnkey solution development kit that we just launched. It's called the Smart HMI solution. And that's kind of showing the real potential of using the RT1170 with its 2D GPU, with its camera interfaces, with its graphic. So basically, you can utilize that to do even like 3D face recognition for machine learning with the application, with the acceleration of the dual core. So if you look at the application on the left, basically, the idea is to have the RT1170 interface with, different kind of sensors and the camera to do facial recognition and other kind of, recognition or interfaces, and then has its rich graphic capability to do like the whole control panel. For example, right now we're showing like a coffee machine, to select your own flavor based on, the identity of the user. Another good example to show the potential of the RT1170 would be the, the industrial drive development platform that we just launched. By this one, we're actually using the RT to drive 4 PMSM motors at the same time with FOC control. So again, showing the capability of the high processing capability. And also we have a 1 gigabit Ethernet to connect it to any kind of industrial motion controller. So that kind of fits perfectly into a factory automation application, also with tons of other communication or connectivity peripherals, things like the CAN-FD. Okay, so lastly, after introducing the RT1170, I kind of want to make some noise for our new members that's going to join our i.MX RT family or i.MX RT series really, really soon. That's going to be the i.MX RT1180. So for this one, we're really going to focus on multi-protocol networking with the network switch integrated onto the device. We also have upgraded security features on there, and it's really designed for efficiency. Okay, so with that, I'm gonna hand it over to Kyle.
Okay, hello. My name is Kyle Barrett. I'm from PHYTEC. First of all, thank you, Daniel, for that presentation on the RT processor family. The next question many of you might ask is, how can I get my hands on this thing? How can I get started quickly with an RT processor? If you're not familiar with the concept of a SOM, PHYTEC builds a printed circuit board assembly around the RT1170. And we include other important components such as the DDR, NOR flash, and RTC, components which are necessary to complete your embedded system. One side of the module has connectors allowing you to plug the SOM into the carrier board that is unique to your application. So everyone's carrier board is going to be a little different based on the IOs that you need. That's just, that's how embedded systems work. So the basic steps are simple to get started. You choose a processor, in this case, the RT1176. You purchase a development kit for the processor, and you start working on designing a carrier board with it. Then finally, you deploy the SOM into the carrier board for your end application. So a big advantage here is we've completed the difficult portion of the PCBA design process around an MCU. This allows you to easily get started and get to market much faster. On top of that, buying a module means PHYTEC's hands-on engineering team will support you throughout the development phase of your project, and we will continue to produce and support our SOM for the entire life cycle of the RT1170. So NXP is committed the 1170 to its longevity program through 2036. So that means you have at least 13 years of support from us and PHYTEC for this product. And that's not just a marketing ploy. We still have SOMs we provide to customers that they've been buying them for almost 20 years now. So we're serious about our commitment to providing our products long term. Now, what does our phyCORE-RT1170 SOM actually include? Again, it's every key component to your embedded system. One of the great things about SOMs is that they're configurable. What you see on the screen here is our default configuration, but we can select which components to populate. We can change the memory density, we can change the processor. So for example, if you didn't want to run with the 1176 and you just wanted one M core from the 1171, we can populate that. Same package, no problem. And importantly, as components go through their own life cycles, our long-term support means we take care of the lifecycle management for you. What does that mean? It means as DDR or NOR chips change, or as their manufacturers EOL them, we will qualify drop-in replacements for you. That's something we take care of. Takes a lot of work out of your hands. So we will document the impact of that change, if any details of the DDR change or the NOR flash changing. We'll make it as easy as possible for you to keep on buying the SOM with no impact to you. Now, if you'll need a development kit to get started, the natural question is, what features does the carrier board in the development kit support? So you can see here, our carrier board comes with dual Ethernet. Of course, it's going to have the system and module on there. Supports 2 micro USB 2.0 on the go ports. You got a micro SD card slot and M2 connector. The idea here is to make it easy to work with so you can just get working with that RT11 processor as quickly as possible. And it comes in a small package. It's 100 by 72 millimeters. When you purchase the kit, what comes in the box? Pretty simple. You got the SOM, you got the carrier board, and we try to make it really convenient. If you don't have a USB cable, Ethernet cable on your desk, we throw those in the box as well. Software, I will touch on software in a moment. I do just want to recap. So the first step to getting started with an RT11 processor, just pick up one of our development kits. This gives you not only the system on module, but a matching off-the-shelf carrier board. This allows you to get working with the hardware generally in 30 minutes or less. production level hardware will be available in Q3 of 2023. That's Q3 of this year. But alpha development kits are available direct from our website via pre-order today. Alpha hardware is pre-production hardware that we use to validate our design. When you pre-order a kit on our website, you will receive an alpha development kit. But we have those in stock today. It's limited availability. We have, I think, 25 kits. We can ship those today if you pre-order. When the production level hardware is available, we will replace the alpha hardware for you with the production hardware at no additional cost. So again, we're trying to make it really easy for you to get started now with this processor. Now, I didn't talk about software. So when you place a pre-order for one of our RT1170 development kits, you can use the MQX code at checkout. When you use this code, the kit will come loaded with a trial version of MQX, courtesy of our friends at Embedded Access. MQX is a real-time operating system, which of course you will need if you're going to work with a real-time processor here. And with that, I will turn it back over to Doug to hear about the software side of things on MQX. Thank you.
Thank you, Kyle. Does my screen look okay?
As of right now, Doug, we can't see your screen.
Oh, hang on. There we go. How's that?
That's great. Thank you.
Okay, thank you, Kyle. Thank you, Rachel. As mentioned, I'm Doug Bruce from Embedded Access, and we're the experts in MQX, and we're a gold level partner of NXP. So MQX has been available for almost 35 years, actually, and there's many tens of thousands of unique applications out there using it. Many of you have been using it for years and years. In case you're not familiar with it, I got one slide here just to give you a bit of an overview as to what it is. The name MQX applies to the operating system, but it's also used to apply to the full platform, which I'll cover in a little bit. But at the core of MQX is a scheduler, like all operating systems, and a small set of core services. And this is the minimum amount that you need. Way back in the day, when footprint was an issue, you could scale it down to a tiny footprint, but you also have at your disposal a full set of optional services and a series of low-level drivers. And these I/O block drivers are for block-based interfaces. And on top of that is an I/O subsystem, which is unique to MQX, actually. So it's using a POSIX-like interface. So you use fopen, fread, fwrite to interface to all the block-based interfaces. And this, coupled with the fact that we've kept the API of MQX consistent throughout, makes it very, very easy for you to migrate from an older environment, either an older version of MQX and or a different CPU, to a new environment like the RT1170. It also includes the Ethernet interface, Wi-Fi, USB, and on top of that is host and device class drivers for USB, RTCS, which is our full TCP/IP stack, MFS, which is a FAT32 file system. There's the shell, which is a command line interface. And outside all of this would be your user application. And we draw it this way because you can access all the different key components of MQX directly from the application code. You don't have to go through different layers. Now, I mentioned it's a full, not just an operating system, but a full environment. So just a couple of key highlights of what's also at your disposal is IPv6 support in the TCP/IP stack. There's TLS support by way of embed, or there's some third-party solutions that we've integrated in as well. Lewis scripting language, a web server, some IoT protocols like MQTT, REST, XMLs, JSON, CJSON. I'll cover RP message a bit later. Many of the MISR rules, the ones that apply and make sense from an MQX environment, conform to. And there's a compression decompression utility called zlit. And I mentioned it was almost 35 years ago MQX started, and from the beginning, it's always supported a multi-processing environment. Way back when, of course, it wasn't two cores on the same die, it was a CPU and a DSP on the same board. But we've extended that and carried on that support ever since. And it supports communication and synchronization through a number of different means. We'll see a bit later a feature in the RT1170 called the messaging unit. And it also supports an interprocessor communication channel. So this is a communication link. And RP message is also a communication link. In some cases, there's hardware-based mutexes. It supports a variety of asynchronous processing, either through unique images per core or shared images. And it supports the configuration of your environment through config files, where you assign in advance the peripherals that you want each core to have access to, but you can also configure that and transfer ownership on the fly. One thing to keep in mind, though, is that the features available here that I just mentioned are dependent on the environment that you're using. So you wouldn't ever use all of these at the same time, but I just want you to know that they are available, and the ones that would make sense are dependent on your environment. So in a multitasking application, regardless of whether it's on single core or dual core, you have access to a number of different synchronization and communication schemes. I'm sure you're familiar with these: semaphores, mutexes, events, and message passing, and you always have access to those. But that's enhanced in a multi-core environment to allow that synchronization and communication across the cores by either a hardware-based means, such as events or mutexes, or I've also mentioned this intercore communication link. And so a bit more on this IPC communication layer. What it is a means of allowing tasks on one core to interact with tasks on another core in the same way and as easily as they can with tasks on the same core. So this is supported by all different architecture types, and includes message passing, task creation and destruction, and synchronization, but to keep in mind, you have to use what we call the full-featured version of semaphores and events. MQX also includes a lightweight version of both these features, but for intercore communication, you would need to utilize the full-featured version. And I've got a couple of animations here just to highlight how this works. So on the left is a number of tasks. I've only showed 3, but it could be any number on core 0. And on the right, again, any number of tasks on core 1. And between the two is the IPC link. Now, this can be established over any communication link you have between the two cores, whether it's serial or I2C or SPI, or maybe something that's hardware specific. So if you have a task on core 1 that's waiting for a semaphore, the semaphore could be posted by any other task on the same core, or it could be posted by a task on the other core. And when it's posted, the waiting task will become unblocked, and it's free to go and continue on the execution of its code. And another little graphic for message passing, just to illustrate how that works. A task on core 0 could be interested in sending a message, so it grabs a buffer from the queue. It fills its content into that buffer, and then that buffer is sent over to a message queue of a waiting task. That could be blocked waiting for this message, or it could just be polling periodically for that message. Once it sees it's there, it can read the content, and then it would return the buffer to the queue. So there's 2 main categories of processors that, multi-core processors that MQX supports. The first category is homogeneous, and as the name implies, both cores or all cores are identical. And the code then will run in either what's called a lockstep mode or a parallel decoupled mode, the former meaning that both cores will be running exactly the same line of code at the same time always. And the latter implies that both cores are running independently. In both cases, you're running MQX on both cores. This is less common environment, but a couple of examples from the NXP portfolio. In the Core IQ family is the P1025, and in the automotive space is a PXS30. The other main category and more common is heterogeneous, and as that name implies, the cores are different architectures. Typically, one will be much larger and has more computing power than the other smaller core. And in this case, since they are different cores, you have to compile the code differently. The code would be running independently. And you can have either MQX running on both cores, or what's typical in the i.MX family of processors, MQX could be running on the smaller M4 core, and something like Linux could be running on the larger A core. Linux has embedded in it RP message, which you heard me refer to. NQX has an enhanced version of RP message, which is compatible with the Linux version. And it supports multiple pipes, and within each pipe can have multiple endpoints, and that's all configurable on the fly. So some examples, I mentioned the i.MX family, 6, 7, and 8. It also supports the Vibrid, which has an A5 and an M4. Of course, today we're talking about the RT family, and in particular the 1170. And Daniel alluded to a couple other options that are multi-core in that same family. So in addition to the IPC mechanism for synchronization and communication, the 1170 has a unique feature that you can use in addition to or in lieu of the IPC connection, and that's called the messaging unit. And that is a piece of hardware IP located at its core, and it's used for interrupt handshaking, event signaling, and simple message passing. The MU unit is here in the middle, and you can see it can generate interrupts to either core and has a small bus. We'll see how that works. So there's a couple of different ways you may want to use this, and one is a synchronization scheme, and that is similar, not the same, but similar to basic synchronization through the IPC, such as sending a semaphore or mutex. And from the application code, the messaging unit has an API that you can call directly, and it's saying that you want to send an event over to the other core, and once you call that, it would generate an interrupt. And there's also a small payload of 4 bytes here if you want to send some data over to the other unit. So a very simple but very fast and efficient way of using the messaging unit. You can also use this in a more sophisticated way, and that is by sending a full message over to the other unit. And on top of the messaging unit is the RP message block I've been talking about. And on top of that is the RTCS, which is our TCP/IP stack. And then your application code would interface just to the TCP/IP stack. And it interfaces to exactly the same way it does to send a message to a remote device over the internet. It's just using TCP type socket interface. So when you initiate a message, it goes down through the stack. The RP message would notify the messaging unit to generate the interrupt. And the data actually transfers between the 2 cores through the RP message area through shared memory. And there's a couple of things that are unique to the 1170 I want to bring to your attention. And this needs to be considered upfront when you're getting into your design. In particular, the code for the M7, so on the M7's on the left and M4 on the right, the code for the M7 typically, in the out-of-the-box example, runs from QSPI flash here. And when the compiler, you ask the compiler to compile the M7 code, it automatically actually compiles the M4 code at the same time. and embeds it into the same image that gets copied up into QSPI Flash. And on boot up, you don't have to do anything about this. It happens automatically. In fact, it's before the application's even running. The M4 code is copied to an alias region in OC RAM. OC is on-chip RAM. And this acts as a backdoor to the M4 core. And so the code gets copied into this region. The M7 thinks it's in this memory address. And at boot up, the M4 is notified, this code is made available to the M4. And it thinks it's running in a different memory space, but it's really mapped over to the exact same physical location where its code is running. So the M4 runs code from RAM in OC RAM, and the M7 is running its code execute in place from Flash. You can see there's other memory regions here. Here's the 8K shared memory region. Both cores have that, and this is where RP message will put its payload when you're sending a full message back and forth between the cores. There's also the on-chip regions and the SD RAM regions. Like I said, out of the box, the example runs the M7 code from QSPI Flash, which is the most common because you can put up to a 1 gig flash here. If you really want, you can relocate that code into other regions here. So this is part of your design considerations, the memory available or the memory that you want to put on the board, that sort of thing. You need to think about these sort of things up front. And one last slide is similar information, but in a bit more detail here. And I show it this way just to highlight the fact you do have many different options here for memory in both cores. At the top on the M7 is the QSPI Flash region. I'll also highlight the shared memory region. Both cores have same address, same size, and that's for message passing through RP message. And here is this alias region where the M7 copies the M4 code to, and the M4 thinks it's got the same size. It thinks it's at its address, but it's really physically located elsewhere. The M7 maps it elsewhere. And you can, like I said, you can move where the M7 core is. That requires a change to the linker file. Certainly that's something you can do on your own if you're familiar with linker files and how that works. I'd also mention that if you do need access to something like that, or migration of your code, any technical support or development services, that's available through NXP. It is the MQX gurus that are providing the support and development services to you, but that all runs through NXP. And that's, well, there's the copying the code down there. That's mostly what I wanted to cover. Rachel, the outset, mentioned a couple of the key takeaways that we have. I know you can download the package of slides if you like from the GoToWebinar system and access these links for various resources to the PHYTEC phyCORE webpage and reference material there. There's a landing page for MQX and other training materials. If you want to reach out to Kyle or anyone at the PHYTEC sales team, there's the email address for them. I'm from Embedded Access, but you can also reach me through NXP email address here. And we wanted to leave a maximum amount of time for questions, so I think I'll pass it back to you, Rachel, and we can open it up for Q&A.
Okay, excellent. Thank you, Doug. We do have a few questions already, and please, if you have more questions, enter them now. Before we dive into the questions, we want to run a very quick poll of audience. So I'm going to launch these polls now, and you'll have a few seconds or a short time to answer. The first poll is, are you likely to use NXP, MQX, in future projects, according to your current plans? So please vote on that, and I will give you just a moment. Okay, thank you all for voting. I'm going to go ahead and close that one down. The next poll is of the choices available, sorry, I need to launch it. Which IDE are you using with your MCU project? And sorry, there should have been an other choice, but I don't see it there. Okay, thank you for that. Close that one down. And then the final poll question is, are you likely to use a PHYTEC SOM in your next product or product upgrade? Still see the votes coming in. I'm going to hold off just a moment before I end this poll. Okay, so we'll go ahead and close that one down as well. And hopefully we're back to the screen with the resources there, the summary screen, and we'll go ahead and get started with some Q&A. The first question would be this: is it mandatory to use both cores in the RT1170 with MQX? Some variants of the RT1170 family only have the M7 core, so how does that work?
Okay, good point. No, you don't. There are variants of the RT1170 family that come with just the M7. You can have PHYTEC populate with a single core version or dual core. So regardless, you're welcome to do either. The package you get supports both. And it's actually quite straightforward to migrate a single core to the dual core or a single core version in a dual core environment. You simply assign the tasks to the core that you want them to run from. So no, it's not mandatory.
Okay, thank you. Next question for things like PHYTEC. Where are the PHYTEC SOMs manufactured?
Yeah, sure. So PHYTEC SOMs are manufactured at our manufacturing plant in Mainz, Germany. So it's our own manufacturing. We don't contract it out.
Okay, thank you. And just scrolling down through the questions here. I don't know, Doug, if you can address this. When would someone choose MQX over Zephyr?
Over Zephyr, that's a good question. You know, Zephyr's got a fair bit in there. I guess it depends on your environment and requirements. It's very easy to port to MQX, and not everyone's open to using open source code for a variety of reasons. Could be legal or technical. I'm not going to, kibosh any other offerings out there. If that is what makes the most sense for you, you can go ahead and use that. But I think what you'll find is in there. You'll find in MQX as well.
Okay, thank you. And the next question I have is TAD or TAD, sorry, I don't know how to say that, supported for MQX over the IDE MCU Expresso?
So does MQX support the IDE and MCU Expresso?
No, there's TAD, I'm not sure, TAD or TAD.
Task-aware debugging, yes. So that acronym refers to a couple different things. So there is a plugin that we provide with MQX, and that provides task-aware debugging right in the IDE environment. So if you hit a breakpoint or pause it, there's a great number of windows you can open up to look at the state of the internals of all the various kernel objects available to you. Sometimes we use that for the call stack, and if you can see the call stack for all the different active tasks. And that's also supported in the latest version, or at least the later versions of MCU Expresso. And so when you hit pause, you can see the call stack for all the various tasks in your application.
Okay, thank you. I have a question for Daniel. The question is, do I have to use external flash with the i.MX RT?
So the answer would be yes for most of the RTs. We do have two families. If you see the part number, like for example the RT1064, that ends up with a 4. So there are two families. One is RT1064 and one is RT1024 that does have a integrated flash. That's 4 megabytes.
Okay, excellent, thank you. The next question is for PHYTEC, and I'm going to condense it, but basically the question is there a SOM available for the i.MX 8M Plus?
Yes, yeah, we do have 8M Plus SOMs available and dev kits available as well. So happy to talk with anyone who's interested in that product as well.
Okay, so yeah, this for the person who sent that question in, I'll make sure your full question gets over to PHYTEC, and I imagine they'll be reaching out to you directly. Next question, this is for Doug about MQX. Does MQX RTOS support POSIX API, POSIX APIs? And if so, please list the available supported APIs.
The API is POSIX-ish. It's not 100% compliant with POSIX. What we do have for people that are porting legacy application code that was written for truly POSIX-based interfaces is a wrapper layer that goes on top of MQX, and it converts, I don't know if it's absolutely every API, but a great number of the APIs to MQX. So your application code would think it's running pure POSIX, and that's running on top of MQX. That's a separate add-on thing. It's not normally provided with the package, so if you can reach out to me and we can talk a bit further about that in terms of your requirements and what this wrapper layer supports.
Okay, thank you. I just noticed that the handout is not available to you guys, so I'm going to take a quick moment and get that added because I had a request for some of the links that are showing on the screen, and they should be available in this PDF. So my apologies that it was not there. I'm dragging it over right now, dropping it in, and it's uploading, so within a few moments you guys should have access to that for the links. Next question. We have so many questions. We're definitely going to have to do some of these offline. Let's see. Is there a license? We have a few questions, Doug, about the license cost for MQX, or is MQX free or open source? Doug, I think you might be on mute if you're answering.
No, sorry. Did you hear MQX version 4? And what's the question now?
The question is MQX free? There's another question, is an MQX for NXP open source? Another question, what is the licensing model for MQX?
Okay, so it's not open source in the sense that it's under typical open source Apache or other licensing terms. It's under an NXP proprietary license agreement. So from that standpoint, no, it's not open source from a legal point of view. So a licensee is allowed to use it for whatever they're licensed for, but you're not allowed to. And you get the full source code. You can do whatever you want with it internally, but you cannot, post it and provide it outside of your organization, that sort of thing. It is not completely free. It's a low-cost license model. It starts at $6,000 for a single product license, and so it's more than free, of course. But what I typically say to people is that $6,000 is about a week and a half's loaded cost of one developer, and so it really is quite low cost, and that includes the full package.
Okay, thank you, Doug. This question is for Daniel. Daniel, do the M4 and the M7 use the same address space?
So I assume the person means memory address. If that's the case, then we do have the M7 and M4 does have part of the address shared, and they do have their own address for some what we call the tightly coupled memory space.
Okay, thank you. Let's see. Question for PHYTEC. Sorry, just a second. Yeah, the question is, how soon can I get a development kit?
Sure. So we have alpha hardware, the development kits available today. So you can, it's called a pre-order, but if you place that pre-order on our website, we can ship those for you this week. And then as soon as the production level hardware comes out later this year in Q3, we will replace that for you with the production level hardware.
Okay.
So today.
Thank you. And as long as I've got you talking, the next question I'll give is, what kind of technical support does PHYTEC offer?
Sure. So we have a team of embedded systems engineers that are dedicated specifically to helping our customers with their design and wrapping up and making it all the way to production. So there's a few different ways of accessing that. It's really dependent on how you work. So there's a ticketing system. You can go online and just open a ticket and access our engineers directly through there. We also are happy to work with email. You can even call in and we'll send you an engineer, no problem. So we try to make our customer engineering team very accessible for people working with our products.
Okay, thank you. Let's see. Next question. I'm trying to pick the most general ones. We've got a lot of detailed questions here. Question for, I think this one's for Doug, could be for Daniel. I don't see the MQX RTOS listed in the latest RT1176 SDK. Will it be added?
In the SDK?
Yeah.
Since MQX is licensed separately, it's not provided. If you generate an SDK on the MC Expresso webpage, it's not embedded in there. So no, you won't see it. But if any licensee is provided a full source code package, and what we contain in there is the relevant components of the SDK for you.
Okay, thank you. I have a couple of questions about SDRAM and DDR-RAM. Like, this question says, the supported memory is SDRAM 200 megahertz at 1 gigahertz CPU. Why not DDR? Would that be a question for PHYTEC or for NXP?
So I think architecture-wise, we usually see the MCU that could be related to the architecture of the core and the bus. That we usually will see a DDR, on more of a Cortex-A core-based architecture.
Okay, and then this other question is a question: does the PHYTEC SOM have DDR4? Kyle, can you address that one?
Yes, it does. It has DDR4, correct.
Okay. What embedded hardware debug features, ITM or ETM, are available for each core? Are any available on the SOM?
So we just use a JTAG port for debugging the ARM cores on the RT. So we can definitely get back to you on with more detail on things like ITM and ETM if you need.
Okay. Sounds good. Thank you. A question to Doug. Oh, never mind, that was just answered. Okay. Well, let me see if I have any more over here. Next question for Daniel. Can I boot from the Cortex M4 core instead of M7 on the RT1170?
Yes, the option will be, either boot from the which is default is to boot from the CM7, and we do have an option to boot from the CM4.
Okay, excellent. And another NXP question, Daniel, can I replace an NPU with the i.MX RT for the same application?
I would say, you know, it really depends on what kind of applications, and you know, it really depends on if you want more real-time aspect, or if you want more of an operating system kind of aspect. Also, like your preference of choice. Do you prefer a RTOS based solution, or do you prefer a Linux or Android based solutions?
Excellent. Well, it looks like we're coming up toward the end of the hour, and although we do have more questions, these are more detailed questions. So if you didn't get an answer here, I will make sure that the appropriate connections have your questions, and they'll reach out to you via email. I just want to thank everyone for being on the call today. Especially thank you to our presenters for the great information that you shared. And of course, thank you to our customers and attendees who joined to learn more about this solution. We will be sending out an email to follow up with a link to the recording and the slides for this webinar within about 7 business days. And if you have any questions, please just reach out to us, and we're happy to help. So thank you everyone for being here, and have a great rest of your day or evening. Bye.